Hello and welcome everyone. Today we have a talk by Niels Simonides. He's a software engineer at Vlog and he is currently working for DHL Parcel in the Netherlands. And he will be talking about domain-driven design. I must admit that I'm a little bit skeptical about domain-driven design, so I'm really looking forward to your talk, Niels, and maybe convince me a little bit in the end. So Niels, the floor is yours.
Yes, thanks for your introduction. In the next hour or so, I'm going to give you a brief introduction into domain-driven design, also DDD for short. Personally, I encountered domain-driven design a few years ago, and basically since then I was intrigued by it because mostly when people think about software development, they think about writing code and things like databases and REST endpoints. And that's, of course, true that it is part of software development, but there is also a large part before you can start writing code. Because, most of the times you're actually solving a business problem, but how do you know what problem you are solving? And how do you know if you model that problem right? Personally, I think every developer is capable of writing working code after a few years of experience. But then after that, what do you do? And I think what I see in the companies I work, for example, is that there is a lot of improvement space in the process before you start writing code. I hope to tell you something about domain-driven design. If there are any questions, please save them until the end of the presentation, because there will be some room then to answer those. Domain-driven design is quite, it's not a single thing. It's a quite abstract term. And the next bullet points, I will briefly try to explain what rules they are. So it's a toolkit for software design, basically an approach for software design. In that toolkit, there are different tools which help with you designing and implementing software. And that goes from high strategic level to also low tactical patterns for implementation. And the catch is that this happens in close collaboration with the people in the business. And domain-driven design calls these people the domain experts. And the goal is to model the business domain explicitly. What you see a lot in software projects is that the code implementation does not model the business domain exactly, because the developers are making different abstractions and there are terms in the code where the business never heard of. So that makes communication about the code and the business problem a little bit harder. And domain-driven design tries to solve that with the help of a ubiquitous language. Like I said, if the code is not in sync with how the business talks, then basically every time you communicate, you have to translate from what the business is saying to the code, but also the other way around. So if there is a problem in the code, it's hard to explain to the business what the problem is, because there is a translation in between. And if both the software and the business talk in the same language, the ubiquitous language, then communication becomes much easier and there is no room for misinterpretation and stuff like that. But I will tell more on the ubiquitous language later. Domain-driven design was introduced by Eric Evans in 2004 in his book. Domain-driven design is not a static set of tools because it also evolves over time. For example, one of the techniques called event storming, that one is now often viewed as a core concept in domain-driven design, but it was not in the original book. So it's not static. And it's also not intended to use in an all or nothing fashion. So you can pick whatever tool you like from domain-driven design and apply that. And if another tool doesn't fit your use case, then you don't use it. It's simple as that. And for me, it's also a kind of mindset, because when you're busy with domain-driven design, then you also start thinking from a different angle. Yeah, and that helps in your day-to-day job. So in this presentation, I work from high strategic level to low tactical level. But yeah, more on that later. Domain-driven design is about closely modeling your business problem. And yeah, to understand what that means, I first want to explain what a model actually is. So in this image, you see a model of the world. And more specifically, it's Mercator's model of the world. And Mercator was a Flemish cartographer back in 1569. And the image you see here is, of course, newer because there is much more data. But the projection and how it's displayed, that's the same as when Mercator yeah, kind of invented it. And this model had one specific purpose, and that was navigating the oceans. So if you, on this map, doesn't matter from which point to which point, but if you draw a line between 2 points, for example, Vlissingen and Bonaire, and you read how much degrees that line is. So I think in this line, it's about, yeah, 325 degrees or something. And then if you follow this number on your compass, then you're more or less end up in Bonaire. So yeah, this was very useful back in the days, and it was widely used for navigating the seas. But then somebody thought, hey, this is actually quite a nice map of the world. Can't we also use to teach children about the world? And then, yeah, a whole generation started thinking that Greenland is the same size as Africa. But in fact, Greenland is only 14 times smaller than Africa. So yeah, there is a model, and then it evolves. And then it's maybe not useful anymore. So if you want to compare country sizes, that's not possible with this model. So yeah, if you want to compare sizes, there are other map projections which are better, like this one. And in this one, you can compare country sizes. But yeah, what if you want to navigate? I think that's a little bit harder with this model. And also, if you want to know, for example, which country has the biggest population or the most oil in the surface, that's also something you cannot do with these two models. So what you often see in software projects is that a model is built and it has a clear single purpose, for example, comparing sizes or navigating. Or yeah, let's say a Mercator's projection. The model was built for navigating, but then a stakeholder or a client comes up and says, hey, I also want to use this model to compare country sizes. And yeah, the problem with software development yeah, is that everything is possible. So you can come up with some smart formula, which takes the distance from the equator and then calculates the size of a country. But then the boundaries of what a model is supposed to do fades. And that's what you often see in software projects. So something is nicely designed and has a clear purpose. But then a new requirements comes in, and that's pushed into the same model. And then you have to create weird abstractions in your model to fit everything together. And yeah, it becomes unmanageable and problems arise because if you fix something here, something else breaks there. So basically, you cannot put everything, the real world, so to say, in the same model. And in that sense, realism is a distraction. Because in software, everything has to have a single responsibility. Otherwise, it's unmaintainable and untestable and stuff like that. So when you keep piling up different responsibilities, the borders fade, and then the purpose becomes unclear. And there is a term for this in domain-driven design, and it's called the big ball of mud. And in a big ball of mud, there is basically no structure. There's no boundaries inside the model. And yeah, if you look in the code, it's basically a spaghetti jungle. And also, if you look at the dependency graph of a big ball of mud, then it probably looks something like this. So everything is connected with everything. And if you fix something in the top left corner, then other features in the bottom right corner will break. It's totally unclear where one model starts and another ends. And yeah, because models are also used in the whole application, they tend to be very abstract, and yeah, they need to cover almost every concept inside the application. So yeah, that's unmaintainable, and it also causes a lot of accidental complexity because things are duct taped together. And personally, I think this is a nightmare for every developer. So yeah, like I mentioned before, in domain-driven design, there is a concept called the ubiquitous language. And this is one of the tools which can help you to prevent a big ball of mud. Because yeah, everything inside your software needs to have a name. But language is ambiguous, and that's also why communication is hard in a software project. So that's why the ubiquitous language is one of the core concepts of domain-driven design. And it's important that everybody in the team and around the team speaks the same language so that there's no misinterpretation. And yeah, the goal of the ubiquitous language in domain-driven design is to develop this language together, so with everybody involved in the team. And it also needs to be expressed everywhere, so in the conversations between people, but also in the documents, and also in the code. So there shouldn't be terms in the code which are unknown to the business, and also the other way around. And communication and language are a bit hard because of the term called lexible ambiguity. So if I say this sentence, I saw bats, then you absolutely cannot tell what I exactly meant, because yeah, there's something in your head popping up right now, which it might mean, or which might mean what I tried to say, but it doesn't have to be. And there are at least 4 different meanings to the sentence. So the first one is, maybe I meant that I use a sharp tool with teeth to slice baseball bats. Or maybe I meant that I saw 2 flying nocturnal mammals. Or maybe I saw 2 baseball bats, and now you probably feel it coming. Maybe I meant that I use a sharp tool with teeth to slice nocturnal mammals. So without context, it's impossible to know what something means. And that's also true in software development. So that's why it's important that everybody develops a shared ubiquitous language, so that somebody says something, the other people also know what it means. So there is no misinterpretation. And yeah, this has to express itself everywhere. If you don't have a ubiquitous language and people constantly need to interpret what you're saying, then basically you are paying an incoherence penalty every time, because when I say something, the other has to interpret it, but there's room for misinterpretation, and that's all room for error inside the actual software product. So for me, this quote really sums it up. And the opposite direction of this quote is also true, because this quote says something about when you're designing a product, but after the product is running in production and there is a bug or something, and with bug, I don't mean something like a null pointer exception, but more like a bug in the process of the application. So maybe a certain edge case is not checked or whatever. In that situation, it's also useful to have one language, so you can also communicate back to the domain expert and ask, okay, what should the application do in this case? And then, yeah, they can of course help you to find the solution. Yeah, and when there is no ubiquitous language, this is basically what happens. So there are different layers of translation between the different people in the team. And yeah, like you will see, the end product is completely different than what the business wants. So yeah, that's basically what happens. If there is a ubiquitous language, there doesn't have to be translations between the people. And then the end result should be the same as what the first one is saying. And this is also like the telephone game you probably played when you were in primary school. In the end of the line, the result is something completely different than at the beginning of the line. Because language is also about creating a shared view of reality. And one of the techniques to do that is event storming. And event storming is a workshop-based method to find out what happens in a certain domain and to effectively distribute the knowledge about the domain to everybody who needs to know about it. So most of the times it's information flowing from the domain experts to the developer. But what you often see in an event storming session is that also it clears up things between different domain experts because often they have their own expertise and their own area where they know a lot about. But if you model a software product, it's most of the times complex and also crosses the borders between the knowledge of the different domain experts. So that's interestingly to see because the domain experts often think they know everything. But then if you map out the whole process, then they also discover, oh, maybe I didn't know anything. So everybody basically has a piece of the puzzle. And also all those people have to be present at the same workshop. So it's a bit like this image. It's called the blind man and the elephant. For example, one person thinks, he's holding for example, the tail of the elephant, and he thinks it's a rope. Another one thinks it's a snake. Another one thinks it's a spear, and so on. And this is, most of the times how people enter event storming workshops. But then, at the end, they will discover that they are actually dealing with an elephant and not the individual components of it. So it's quite a nice analogy. There are a few ingredients you need to have when you are doing an event storming session. It's quite easy. You only need an empty big wall, sticky notes in different colors, and a lot of markers to write on the sticky notes. Or the first step is to come up with all the events which happen in a domain process. Well, this presentation is now in a meetup. So let's say we want to create a meetup system to organize meetups. So like I said, the first step is to identify the events which occur. For example, you have an event meetup created, or participant joined, or meetup started, meetup edited, meetup announced, and so on, meetup promoted, invoiced, a group created maybe, participant invited, user logged in, or meetup cancelled. And if you really would design a meetup system, there are probably a lot more events, but this will give you the idea. And now it still looks like a mess because they are just random events. So the next step is to organize them. And to organize them, you have to place them on a timeline from left to right in a chronological story. So basically the first thing what happens is a user logs in, and then maybe the user creates a meetup group and then a meetup and so on. And now if you look at it as a story, you can already see that different flows start to appear. For example, the main flow, or some alternative flow if meetup is cancelled, or some asynchronous flow. So yeah, it also happens at time, but it's like a subflow. And if you would do this for all the events, then you're already starting to get a sense of what's happening inside the process. The next step is to add more different colored stickies. And after the events, it's mostly the blue sticky which is added. And blue stands for command. So that's the command which initiates the event. And the events are always in past tense, so meetup created. And the commands are always in present tense. So yeah, they say something about what needs to be happened. And then, of course, you do this for every event, but for now, I only do it for the meetup. You also have the yellow stickies. And yellow is an aggregate. And that's basically the model which is affected by the command. So if a create meetup command happens, then it affects the meetup because then a meetup is created. And the aggregate is also the thing that produces the events. So after a meetup is created, it emits a meetup created event. And remember the term aggregate because it returns also in the next slides. And I think it's quite important to understand those. Then you can also add purple stickies. And these are policies. And a policy is basically a business rule which needs to be checked after a command happens. So in our system, it might be possible that there is a business rule that every organizer only can create one free meetup per month or something. And that, of course, needs to be checked after a create meetup command is executed. And also, a policy can prevent an event from happening. So yeah, if there was already one free meetup, for example, then maybe the meetup created event is not sent. Yeah, what you often see in those workshops is that a lot of questions and discussions arise because people not always have the right answer to stop those discussions take all the time. You can put red sticky notes and you can write the questions on there and then discuss them after the session. There's also small yellow stickies. And with those, you can indicate which actor is executing the command. So in this case, for example, it's the meetup organizer. Green stands for, yeah, it's officially called read model, but it can be a data view or a UI or whatever, but it's the input on which the actor acts. So I think in this case, it can be the organizer landing page, for example, where there might be a button called create meetup. So yeah, that initiates the create meetup command. And you also have large purple stickies, and those are external systems. So let's say we want to send an email after a meetup is created, then we can indicate it with the external email service. And the larger purple ones are because inside the system there's also a whole flow, but that's irrelevant for this process. So that's why you can kind of group those processes with a big purple sticky. And then after you've done this for every event, the result might look something like this. And if you look at this, it looks a bit messy, but yeah, for everybody who was in the workshop, it makes perfectly sense. And also one of the aspects of event storming is that the discussions are very valuable. And after you have this whole wall filled with stickies, there is also a technique called example mapping. And this can help refine the system. So, yeah, so let's say you with example mapping, you create different examples or scenarios for each business rule. So here we had the business rule, one free meetup per month. So then you come up with different scenarios. So for example, when there are 0 meetups, and then also a scenario where there is already 1 meetup. And then you can mentally kind of execute these scenarios on the wall to your stickies. And then most of the times you find holes because there are edge cases you didn't think of. And also the output of an event storming session can then be used for another tool in domain-driven design. And that tool is called bounded contexts. So in the event storming session, you already identified different aggregates, for example, meetup or promotion. And what you often see is that there are multiple commands, but also multiple events feed into and emitted by the same aggregate. So here it's create meetup and then meetup created. But for example, if you would have a command edit meetup, then there's also event meetup edited. But the aggregate, that's still meetup for both cases. So if you group those aggregates together, then you already get a sense of where the bounded contexts in your system are. So for the meetup system, it could be something like this. So we grouped all the meetup aggregates together, also all the promotion aggregates, the user aggregates, and the billing context aggregates. So a bounded context has a few characteristics. One, that it's a unit of consistent language. So in each bounded context, a model has one purpose, and it's used for one thing. And the language can also develop in different bounded contexts. So you can see this as Spanish in Spain and Spanish in South America. They originated from the same language, but then they developed independently, and then there are slightly changes. Yeah, like I said, it contains models for specific problems. So each model has a single purpose in each bounded context. And there is high cohesion in every bounded context, but that's already the result. If you group all the aggregates together, then you're already talking only about meetups in the meetup context and only about promotions in the promotion context. And the book also states that it's important that each bounded context is maintained by only one team, and this is to preserve the ubiquitous language. But one team can maintain multiple bounded contexts. So every model inside a bounded context has specific purpose, and the bounded context is responsible for the integrity and mutability of the specific data in the bounded context. You can basically say that each bounded context is the source of truth for that form of data. Yeah, of course, also the bounded context needs data from each other, but because you cannot have a promotion without a meetup. In the event storming session, you already identified that there are different events. So one of the events which happens in your system is, for example, promotion created. And those events flow between the different bounded contexts. And that's how they communicate together. And for example, a promotion needs to be built. The source of truth of the promotions is the promotion context. And then the billing context listens to that event. And then, it can create an invoice, for example, for the promotion. The next step also in bounded context is to identify kind of the level of the bounded context. And often you have one core bounded context. And mostly in the core bounded context is where you distinguish yourself from your competitors. And And the goal of knowing this is that you can, for example, put your best developers in this team, or maybe prioritize backlog stories for this context, or things like that. Then another thing you can have is that bounded contexts are supporting. And generally, there's no off-the-shelf solution available for the problems in a supporting domain. And basically, the problems in a supporting domain comes along with the core domain. So you cannot build a meetup platform business when you don't have a way to make money. So that's why you need the billing context, for example. And the last type is a generic domain. And most of the times, the problem you're trying to solve in a generic domain, most of the times there is an off-the-shelf solution available. So in our use case, it probably doesn't pay off to build our own user management or user identity provider, because that's just not our core business. And we can better focus on our strategic advantage than building something like this ourselves. So for example, for this, we can use Keycloak or something like Active Directory or whatever. And to further identify the interactions between the bounded contexts, there is a tool called context mapping. And this really helps you think about how you need to integrate different bounded contexts. So for example, like I said, the meetup, basically the meetup data is exchanged, because after a meetup is created, it needs to be built, for example. And what you see on this line is basically the translation from one ubiquitous language to another, because a meetup can mean something different in another bounded context. Because in a meetup context, every property of a meetup is known and also needs to be known. But in a billing context, for example, maybe it only needs the title of a meetup. So a meetup would be modeled differently inside the billing context, maybe only one object with a title. And basically what you see is that this line is sort of translation between the two bounded contexts. And you can compare this with two countries who want to trade. They don't speak each other's language. So there were different solutions then. So either one of the teams or countries needs an interpreter, and then they can communicate with each other. But also maybe if one country or team learns the language of the other country, then they can also communicate. And so there are different options, and one option takes more time than the other. And the goal of context mapping is to identify what interrelationships there are. And when you become aware of them, you know how to treat the other bounded context. And it also helps you to further sharpen the boundaries of each bounded context, because then you know when a concept starts and also when it ends. And also the communication between the bounded context is very loosely coupled. And that also means that controlled changes are possible over time. And this is the opposite of the big ball of mud, because then everything is connected to everything, so you cannot change a certain concept without breaking something else. So this really helps to clarify the boundaries and how they interact with each other. And there are different kind of context maps to describe the communication between the bounded context, but also how the teams behind the bounded context interact with each other. There's a whole list, as you can see. So I won't explain them all, but only a few which are applicable to the meetup system. For the communication between meetup and billing, I think we can use the published language context mapping here. And this basically means that there is an API spec, for example, or an A4 schema or whatever, but the communication is spec'd. And and then both parties know what data is exchanged. And another one is the conformist. And if for the user bounded context, if we solve this problem with something like key cloak, then from the meetup's point of view, there is only one choice, and that is to conform to whatever the user context provides. There is no shared interest. The key cloak is not going to change their API if you need something else. So you just have to conform to it. It's take it or leave it. And by becoming aware of all these, it's basically becoming aware of the power balance between bounded context. And that really helps you making better choices in how you are going to implement it and how you should treat other bounded contexts. For example, another one I want to pick out is for example, if you need to communicate with a big ball of mud, then you know that system is like a mess. And what you can do then is, for example, create an anti-corruption layer between it. And that basically translates the whole big ball of mud, the mess inside it, to a more structured communication pattern. Yeah, until now, I only talked about the high-level strategic patterns. And from now on, I will continue with the lower-level tactical patterns. So those help you more in implementing all these things. So if you want to implement a bounded context, then what's actually inside it? So, for example, our meetup bounded context, possibly it contains these aggregates. So meetup, participant, and location. And also because they all live inside the meetup context, there is no need to, for example, call location meetup location, because the bounded context is already the scope of a meetup. So that makes it simpler. And since the bounded context already forms a clear border within your whole system, you can also see it as a kind of standalone subsystem. And that means that you can implement it as a microservice or maybe as a submodule within a monolithic application. But the point is that the bounded context is always, basically standalone. Let me see. Yeah, in the previous example between the meetup and promotion bounded context, you already saw that they communicate through events. And that's also something you can use inside the bounded context. So for example, if a participant no longer wants to attend the meetup, then at some point, a participant unsubscribed event pops up. And that's basically, I think it's sent from the participant to the meetup because the participant is the one which unsubscribes. And for example, if the meetup wants to hold a counter with all the participants or something, then the meetup can listen to this event and then act on it. Yeah, and for this communication, you don't need a full-blown messaging middleware, something like Kafka or something. You can use something like Spring Events or maybe, just a local broadcast library or whatever. Yeah, so all the entities inside this bounded context are aggregates. And I will now try to explain what an aggregate exactly is. So aggregates communicate through ASIC events. And that also means that each aggregate forms a transactional boundary. So the data inside an aggregate must be consistent according to all the business rules. And that's also means that all the business rules are inside the aggregate. So if you remember, we had the business rule that there is one free meetup per month. That's something the meetup aggregate should check if a create meetup command arises. And because they communicate through events, it means that your whole system will be eventually consistent. So this is what I said about the business rule. So the aggregate itself is responsible for enforcing the business rule. And these are basically a few rules of thumb for aggregate design. Yeah, if your aggregates tend to get too big, then you're probably violating the single responsibility principle. And in keeping them small, it makes it easier testable, and also helps to keep your memory footprint, for example, low. Each aggregate is a single source of truth. And in an event-driven system, a lot of data is passed around. I already mentioned if a meetup needs to be enforced, then the meetup data flows from the meetup boundary to the promotion, to the billing boundary. And then it's very tempting to save, for example, the title. But yeah, that's not a good idea because the title can change over time. And that title was only that title at the point when the event occurred. So it's only safe to save references to the other aggregates and not the data itself. Then when you implement your model, so for example, this model, for example, so you have a meetup, a location, a participant. Then the book of domain-driven designs promotes the use of a rich domain model. So for the meetup, for example, that meetup class would have both properties, which describe the meetup, but also methods which operate on the meetup. For example, a start meetup or save or whatever. And also the business rules are then encapsulated inside those methods. But when domain-driven design was introduced, object-oriented was the most dominant paradigm. And in object-oriented paradigms, the anemic domain model is often seen as an anti-pattern. But in a functional programming paradigm, this is basically different because that supports the separation of data and behavior. So I would say that it really depends on what programming paradigm you're using. If you're using object-oriented, then it's fine to put everything inside the classes. So for example, the meetup class. But if you're using functional programming, then it's better to have only data holders or records or whatever. And then pure functions which return basically new copies of those immutable structures. And there's also a few techniques inside domain-driven design which help you to build better code. And one of the concepts is value objects. Basically, you have entities and value objects. And an entity has an ID. So, for example, this user class is an entity because it has an ID. And this class can be improved by modeling the email address as a value object. So what changed here is that email address is no longer a string, but an object with a string. And that is because, the string type is just too wide, because not every string is an email address. And also that the email address is, for example, backed by a string. That's a kind of implementation detail. If you have an email service which accepts an email address, and you would change the type from string to something else, then you basically have to change it also everywhere in your code where you're doing something with the email address. And by creating a value object, you basically have a holder, and you only have to change the type inside the holder. And this can be improved even further, because now the email address class has a parameter called string, but that's still too wide. So what you can do is make the constructor of the email address class private and create a new smart constructor, which then checks if it's really a valid email address, and then returns the email address object if it's the case. And this helps you to create better type safety inside your domain, because you push all the construction of the objects to the outside of your domain. And then inside the domain, there is no need to check, for example, if your email address is valid. And to implement a bounded context, domain-driven design basically has a tool called Hexagonal architecture. it's often also called ports and adapters. And basically the core of this concept is that the domain is completely dependency free. So in the domain, you have all the objects, for example, meetup and location. And yeah, then depending on your programming paradigm, you have pure functions or whatever with all the business rules. And basically that's your domain. Everything else you build around it. Because the domain doesn't need to know if you're using a relational database or an object store, and if the data is communicated through REST or through a messaging queue or whatever. That's not the concern of the domain. And in a traditional layered architecture, each layer always depends on the layer below. So that also means that if you have your domain layer, that normally depends on your data layer, for example. And with hexagonal architecture, that's no longer the case because all dependencies point inwards towards the domain. So this is then how it looks. And because all the dependencies point inwards, it's impossible for the domain to know how the data is communicated because it's not a concern of the domain. And this also helps you to prevent taking shortcuts, for example, by using the entity class inside your domain or whatever. And yeah, this all helps you to prevent basically creating also a big ball of mud. And also because the domain is completely unaware, testing also becomes easy because yeah, you can use different persistence strategy and easily swap out different basically transport layers around the border. Yeah, for me, there are a few takeaways from domain-driven design. And I think it helps making software development a little bit easier. So yeah, the first one is the ubiquitous language. And that's a tool which you see through every other tool inside domain-driven design, from event storming to dependent context and also the code implementation. And this is also a tool which helps you in the whole lifetime of the software project, not only the design phase. Yeah, and that domain-driven design, it gives you a mindset to really focus on the business problem and not the technology. Because I think a system never should be more complex than the domain it lives in. And yeah, sometimes with technology, it makes it even harder than the business problem already is. And I also like that it's not an all or nothing approach, that you can use whatever you like. Yeah, it's just a big toolbox with different tools. And I also think you don't have to use it dogmatic. For example, you don't have to model every ID as a value object. You can just apply it whenever you need it. And I think event storming is probably my most favorite tools because it helps on so many levels. It helps you creating ubiquitous language and transferring knowledge from the domain experts to the developers. And because it helps you create a shared view of reality, it also helps the business, even if you're not building a new software product. People often realize that they are living in silos and that they all have a different view of the world. And maybe they're already working 10 years together in the same business. And I think it's also always mind-boggling that during an event storming session, the concept is pretty simple. You just have stickies and write things on it. But then when you do that, suddenly the whole system starts to emerge right before your eyes on just a wall. And that's only in a few workshops. It doesn't have to take much time. And then you also see all the boundaries already appearing and how the information flows through the whole system. Yeah, I think it's just very, very powerful too. And I think maybe it's a bit exaggerated, but sometimes it feels that after you've done event storming workshop, it almost feels like that you only have to implement all the commands, the aggregates and the events, and that your system already works. That all the thinking is already done inside the event storming workshop. So yeah, this was my presentation. Are there any questions?
Indeed, there was already some questions in the chat, so I'll ask them for you. So one is, do you come up with just a happy path, or try to come up with all the scenarios in your event storming sessions?
Yeah, that's a good question. What you most of the time see is that people first model the happy path, and maybe also some other alternative paths. For example, if a meetup is cancelled. But then if you're doing example mapping and create different scenarios, then you also discover other paths which you probably forgot in the first place.
Yeah, nice.
So yeah, the other scenarios is mostly the second step when you do example mapping. That's basically the
right,
answer.
and of course you can add scenarios if you forgot something in the end.
Yeah.
Well, then another question about the aggregates. Does each aggregate have its own database to keep state, or how do you view that?
I think most of the times each aggregate is one table in a database,
Right.
and one bounded context has one database.
So there can be multiple aggregates in one bounded context.
Yeah, exactly. For example, in the meetup, we had the meetup itself, but also a meetup location and a participant. And because the meetup is one bounded context, that can, for example, be the meetup microservice, and then it would have its own database with 3 tables: the meetup, the location, and the participant.
Maybe another question. Are there any resources that you would recommend how to master this event storming technique, and then subsequently event mapping?
Yeah, I think you mean example mapping. And I think there is an online community called Virtual Domain Driven Design, and they have like 3-hour workshops where they practice all these kind of things. So yeah, I think you can visit them on YouTube, and yeah, I think you can learn a lot there.
Cool, thanks. Then I also had some questions, because indeed I really like the idea of having a ubiquitous language. But regarding that, of course, there can be data structures like a hash map or linked list or other kinds of things that are actually supporting your domain model. Do you need to include that into your ubiquitous language when you talk to the business, for instance, or is that where the ubiquitous language breaks down and you have your data structures to consider yourself?
Yeah, the ubiquitous language is meant to only basically include business concepts. And if you're using a linked list or whatever list, that's a kind of implementation detail, and that's most of the time not relevant for the business problem. Maybe you need one type to solve the business problem, but for the business process itself, it's not relevant.
Right, and then you would actually consider a different mapping, as you had with your example with the maps of the different projections, to actually have the same data and the same domain in maybe a different context or in a different data structure.
Yeah. Depending on the outcome of basically the business process, you as a developer can decide what kind of list you need, but you also need a lot of business context and what the domain experts really want before you can make that decision, because only after that you know what type is better.
And maybe a last question, if there aren't any others. How can you actually enforce this ubiquitous language? Because I can imagine that once you have a system and you have it running for a couple of years, maybe that ubiquitous language also gets bottled down with all kinds of concepts that you originally did not have in your system, or maybe, of course, people leave, people join your team. How can you actually enforce that the ubiquitous language that you have as a team between business also actually ends up in your system?
Yeah, I think it's in the first place okay that the language evolves if people leave, for example, but then you have to make sure that everything in the code, for example, also. But I think it only evolves if you discover that one term is better than what you used initially. And I think I think it's a kind of organic process when it evolves. I think you don't really have to enforce it, but if somebody joins your team and in the documents it reads meetup and in the code it says meetup and people talk about meetups, I think it's very unnaturally for somebody who's joining then to call this something else, like I cannot come with a synonym, but
So maybe it's the other way around, because you have your ubiquitous language to begin with and you have it already in code. It actually stays more stable.
Yeah, exactly. Yeah. And I think, for example, when you're doing event storming, then because people or domain experts are living in different silos, they often have different terms. And what you also discover then that there is different languages, and you try to consolidate into one language. So the first step of event storming, I didn't told it in this presentation, but the first step is that people first write down all the events which they think happen inside the system. And then you already discover that one person calls it X and another people calls it Y. And then you can have the discussion, okay, you're saying X, you're saying Y, which is better? And then you have a discussion, and that helps to create a consistent language.
Thanks. And then, of course, and there is another question that's saying, what tools do you use to capture all these nodes from the event storming session? But that's then probably a list of stories, maybe indeed. It was suggested to use Jira. Is that something that indeed makes sense to you?
Yeah, because if there are questions, for example, you already have the red sticky notes, so that's something you already captured. And of course, you can create a picture or something after the event storming is finished. But normally you also take a few iterations, because if you're doing this for 8 hours straight, then it does not make sense. So you should keep it like 1.5 hour each session. And then people also have time in between to let things sink in and come up with better ideas. And then you can just leave all the stickies on the wall and continue next week or something else. And then after a while, of course, you need to, maybe Jira is one option. But there's also a tool called Lightweight Architecture Decision Records. And that's a kind of format in which you can quickly describe all the things you need to. But it's of course dependent on what you need to save between the sessions.
The last question that I saw in the chat was domain-driven design. Is it also suitable for short-term projects or with projects where there isn't a high domain complexity? Or would you only recommend it for larger projects and high complexity?
Yeah, that's a good question, because if you're creating a simple to-do list app, which is basically just a quit app or something, then it's probably not needed. But I think when the business is more, when the business problem has more complexity and you need different people and alignment between all the people and stuff, I think then it really is helpful. But for small projects, it's probably not indeed. Yeah, that's more about the high-level strategic tools. But for example, the tactical tools like value objects, that's something you can also use in short-term or more little complex.
Right. So you would just pick the concept from domain-driven design that suits your short-term project.
Exactly. Yeah.
Right. Okay. Thanks. Well, thank you very much for your presentation.